Hello, and welcome to this introduction to probability of Wolfram. My name is Marvikuna, and I'm the statistician here at Wolfram that will be accompanying you throughout this course. I have a bachelor's and master's degree in computer science and mathematics, and I love computational mathematics, such as computational geometry, computational topology, statistics, and data analysis. In this first lesson, we'll explore the question, what is probability? The short answer is probability is the science of randomness. Think of the result of a coin flip, number of patients expected in a day, the range of wind speeds expected tomorrow, the shape of a grid distribution. All are outcomes that can be guessed but not outright predicted, so they imply randomness. If you can't fully predict it, then why should you care? Well, probability answers four important questions. Let's take an example. You bet some money in a casino game. What is the chance that you win? What is the expected outcome? Will you lose most of the time? And if so, by how much? How random is this game? Is there cheating behind the scenes? How many times should you play the game in order to approximate the underlying model? Okay, that's a lot. So let's visualize. To start, what's the chance you win? If the winner is determined by drawing a ball out of an urn, your chance of picking a red ball from this container may vary from very unlikely to very likely. What is the expected outcome? For a roulette wheel, you're expected to lose money overall. Looking at the gray section, the greater the portion of the roulette you bet on, the more you lose. This gives you a range of proportion of money you still have. If the winner is determined by rolling a die, how random is that die? If the die isn't tricked, we expect the die to have equal frequency for all outcomes. Let's throw the die many times and note the frequency. Here, the die doesn't seem to be tricked, since all outcomes are relatively equal. How many times should you play the game in order to approximate the underlying model? If you bet 10 times a day, the amount you win may not clearly follow a trend. But if you bet 200 times a day, then clearly it can be approximated to this blue trend. Why are we talking about games? Well, probability is an old concept, but probability theory was initially made out of love for games of chance, with Girolamo Cardano, the gambler who started it. Then there was Jacob Bernoulli, who was able to prove some predictable behavior over large numbers. And then, pushing further on, Abraham de Moivre discovered the popular bell-shaped distribution that you just saw in the last example. Then, Pierre-Simon Marquis de Laplace, who proved the central limit theorem, a theorem that explains why that bell-shaped distribution is so popular. And then, Andrei Nikolaevich Kolmogorov, who cemented the modern definition of probability. As you'll see in the first slide of every class, the quintessential game of chance is betting on a six-sided die. Most concepts in this course can actually be explained using only two six-sided dice. So if you want a hands-on approach, you'll need two dice. Nowadays, probability is one of the most used branches of mathematics. The field of statistics is based on probability theory. Machine learning uses maximum likelihood as a core mechanic, which can be called maximum probability, and applied sciences of all types use hypothesis testing, which is a test on range of probabilities. So why study probability? Trust me, probability is more than just another math problem. It's a tool to help solve complex real-world problems. Consider this. Anything that cannot be yet fully understood is characterized by randomness. So probability is often instrumental in making new discoveries. This course is designed to allow you to understand the theory from the ground up. You'll learn probability in 6 steps: basic probability, random variables, discrete distributions, continuous distributions, derived distributions, and asymptotic probability. Each section can be learned independently, but this order gives the best logical progression. This course is most useful for college students preparing for, struggling in, or wanting to review probability, as this course covers all notions seen in college-level Probability 1. Professionals needing a practical understanding of probability and statistics, Wolfram language users seeking efficient use of probability functions, and finally, any curious mind desiring an intuitive and deep grasp of probability. In short, as a mathematical subject, probability is essentially the study of randomness. As a scientific tool, probability enables you to analyze any unknown problem with confidence. As an educational hurdle, probability is one of the many tasks that a student should be proud to master. The next lesson will officially start with combinatorics, also known as how to count.